Good evening, Lakshmi. Can you hear me?
Hi, Raghav. Good morning.
Okay, so today we will start with SQL. Let me just
Okay.
share my desktop.
Yeah.
So let's keep Windows on one side, uh, this guy on the other side. Okay, so you can see my screen, the PPT.
Yes. Yeah.
Okay, so coming to SQL, we will just see the basics. SQL is pretty vast. It has evolved over a period of time, and there are many commands in SQL, and it can be really complex if you look at some of the SQLs in some projects. The SQL itself can go for multiple pages, so means it will look like a program, but it will be very complicated. But here we are just going to focus only on the basics. Okay, but this is just a starting point, but this is not sufficient. Okay, when you work
Okay.
on a project with SQL, you have to learn a lot more than what is required, what we are doing here. This is more like a introduction, like what are the things available in SQL. But depending on the DB2 version that you are using, so the features in the SQL can change. Okay, it depends on the version of the DB2 that you use. So in fact, we have the latest version here, but still uh, uh, we are not going to cover of whatever is the latest offering in SQL, because that itself will be a separate course. If you want to specialize on SQL, in case your project needs a lot of SQL, you have to look at it. Then you have to dig in more on your own, or you can take some specialized courses on the particular version of the DB2. Okay, for example, now we are using DB2 version 14, I think. So there may be a lot of features in every version of the DB2. So depending on your project, if they say you must know a lot of SQL for the particular version, so you have to take a separate training on that, or you have to learn it on your own. So that's what I would suggest. Uh, I'm just saying SQL is so big, we are only seeing a very small part of it as an introduction. Okay. All right. So this itself, if you practice, you will find it very interesting. And of course, you can explore the DB2 features. We have one of the latest DB2 versions in this particular system. So if you want, you can explore many of the features which is available in the latest version. So coming to SQL itself, structured query language, obviously, this is meant only for relational database. Relational databases like DB2 or a Microsoft SQL Server, they support SQL. There will be some differences, not a lot, but maybe some differences between one product and another product. Let's say if you use SQL for Microsoft SQL Server, most of it will work in DB2. But the conceptually, most of them will be same. Syntactically, some differences can be there. For example, there's a concept of join. The way the join syntax will work on DB2 need not necessarily work on SQL Server or vice versa. So, but the concept will be same. So that you have to keep in mind. One SQL, if you learn in any product, you will find it very easy to adapt to any other SQL product. Okay, so only the minor differences in syntax and some additional features can be there depending on the product and its. So, but once you learn SQL for one relational database, that is good enough for working with any relational database. Okay.
Okay.
So, what do we do normally with SQL? Basically, the CRUD operations. Basically, you can create objects. Objects mean DB2 objects. Within DB2, we have what is called as objects. The only object that we are going to talk about now is tables. Later on, we will talk about the other objects. Table is one of the objects that we create. Table is nothing but consists of rows and columns. Right. I think here we have only about SQL. We don't. I'm just telling you tables. So the rows and columns, you are going to put data just like an Excel sheet, right? So SQL is going to provide mechanisms or commands to add data. That is what they call as create, update data. Okay, whatever is already there, you can modify it. So that is again done by SQL. Then delete the existing data. Okay, add, update, and delete. These are the basic three operations. But these three alone is not sufficient, because the main thing about putting the data is we want to take the data out in the way we want, like searching and pulling the data and then doing some analysis on this. That's how the businesses will work. So all your business logic will be based on retrieving some data and then doing the logic around that, business logic. So retrieval is mostly used, though addition and modification are done on a daily basis, depending on the kind of database we have. Transactional database, it will happen every second, every minute. Whereas there are non-transactional databases or pretty much static databases, which doesn't change much. Maybe once a month or once a year it will change. So those are non-transactional databases. Within the database, you will have tables which are highly transactional, whereas there are some tables which will not be transactional. I'll just give you a small example. So let's take a bank account. Let me open my notepad. Okay, if you take a bank account, so bank account will have a customer data, right? So customer data can be typically a customer will have a unique ID. Every bank will give the customer a unique ID. Then we will have a name, address, contact details like phone number, email, etc. Right? So this is the customer data. So this can be saved in a table, right, for all the customers. So maybe depending on the bank, it may have, let's say, thousands of customers, right? Maybe if it's a very big bank, it can have millions of customers. Um, so, so, uh, so this is a table which is not very transactional. See, you are not going to add thousands of customers every day, right? These add operations will be limited, right? Maybe a few hundred customers will join the bank every day. And coming to update, so what the customer will update, the customer can update his contact details. Generally, that's what it is done, right? So other than that, hardly any updates will happen in this particular table. Okay. So because once, let's say your SSN is given, or in India, we call it PAN, right? So this is not going to change. Once it is given, unless it is wrongly entered, so you are not going to update this, or date of birth, you are not going to update every time, right? Once it is given correctly, you are not going to update it at all. So update operation is also very limited in a customer table, right? Then what is the other operation we can do? Delete. So this one, they don't do it in commercial databases. So they don't do any deletion of any data. Okay, because for audit purpose, they will not allow you to delete any data. So what you can do normally in these kind of situations, if the customer is no more the customer of the bank, probably, or an employee for an employee database, the employee has resigned. So he's no more an employee, doesn't mean his data will be deleted. The data will be, maybe you will have some kind of status, right? Status of the customer or the employee. So maybe inactive or resigned in case of employee, like that you can have. So you will not actually delete it, you will actually update it. Okay, you will update somewhere a status. Right here, you can have something like customer status. Right? Can you see my notepad?
Yes.
Okay. So this is how the operations will happen, but most of the time, the majority of the operations will be the retrieve operation, right? You are going to retrieve the data multiple times. Okay, this will happen. This will happen a lot. Okay. What can I say? Frequent. So, or very frequent. You are going to access it, retrieve it very frequently. So this every table will have a different type. So this table is pretty much static in terms of adding data or updating data. It doesn't happen that much. Whereas retrieving data, obviously you can do a lot more retrieval many times a day, thousands or even millions of times a day. So this is the customer table. Whereas if when you come to a transactional table, like bank transactions, right? So what are the typical transactions you will do? You will do a debit operation, you will do a credit operation, right? A transfer means it is a combination of debit and credit in different accounts, right? So like these kind of operations, this is transactional. It can happen multiple times a day, even for a single customer, right? Multiple times a day. So there will be millions of customers. So obviously, this every transaction, this add operation will happen, uh, very high frequency. So every second or every minute, lots of transactions will be added. Now then, update. So once a transaction is created, there will not be any update operation. So that will be generally if transactions are not updated, whatever it is, it will stay as it is. Update, there will be nil. Okay, so you don't update an existing transaction. So it will not happen. Obviously, delete will also be nil. So update and you will never delete a transaction. Whatever it is will be there. So whereas add will be very high frequency and similarly retrieval. So retrieval will be also high frequency. You can retrieve the data of the transactions um, in a high frequency mode. Basically, the data table you will access this multiple times for each transaction or each customer request. Let's say I want to see the last 5 transactions. So you're going to access this table. So transactional tables are having very high add operations. Okay. So non-transactional will have very low add operations or even update operations. Okay, that's the thing you have to keep in mind. One of the concepts behind the databases, right? How they are used. Not all the tables or not all the databases are same. Depends on the information that is stored there and how it is accessed. Coming to SQL we have some statements in order to add data to a table. First of all, in order to create an object, so you have to use something called as a create table command. The create table command is required to create a table in which you want to store some data, like create table customer, create table transaction, like that. Then once you have created the table, you can do these operations, right? Insert is for adding records. Okay, then if you want to modify records, you use the update operation. Then if you want to delete the records, which we rarely use, you can use the delete operation. And the most frequently used one is the select operation. Select is nothing but retrieval. So that is the thing. So now they have categorized these kind of statements into multiple categories. This is generally called as DDL, data definition language. Create objects. It will come under. You can also do create or alter. Of course, you can do delete also. So these objects, when you do like table and other objects, that's called as a DDL, data definition language. So these insert, update, and all are come under data manipulation language. It's generally called as DML. And select, sometimes they bring it under DML, but strictly speaking, it is DQL, data query language, right? So, and there is also another thing called DCL, data control language. In this, you will have commands like grant or revoke. So these are something to do with the permissions. That is the security. So the security part of that will come under DCL. There's also something called TCL, transaction control language. So TCL, there are some commands. Basically, the commands are categorized into this. TCL will have commit and rollback. So basically, this is the way of how you want to save the data, or whether you want to do, you don't want to save a data at a specified whatever error if some error happens in between the transaction, do you want to save the data or do you want to undo the operations, whatever you have done? So we will talk about this a little later once we get into the programming, DB2 programming. There it will be a bit interesting to do such programs. Anyway, so these are the basic SQL operations. Let's come back to the PPT. So now, in order to create table will have columns, right? The columns should have what is called as a data type. There are many data types. We are seeing the very basic data types here. Numeric, non-numeric. Within numeric, we have a small integer or decimal. These are the popular ones. Sometimes the number is similar to decimal. Sometimes we also use float and real, means a floating point number. Real will have it's like double in other languages they call it double float. Basically, it will store multiple. The precision will be more in terms of decimal values. So normally, most of the data types it will come under this numeric data types. Normally, we'll either use small int or integer or decimal. These things we can use if required. We'll see that we can create a table with all this. Then non-numeric, we have string and date. Coming to date, we have date, normal date, time, normal time. Timestamp is nothing but a combination of date and time. And it will also have the time part. It will not be just at a second level. DB2 divides the time into what is that? Microseconds. So that means 6-digit number. So that is the timestamp. So timestamp, if you look at the data, it will look something like this. I'll show you in the notepad. Let's go back to notepad. So if I look at timestamp, so the data will look something like this: 2026, let's say 6/12. Then date, this is the date part. Then you will have the time part, let's say 12/33/44. Pick the different number here, let's say 15. Yeah, here I probably changed. So this is the time part, 15/33/44. Okay, it will not have a colon when you display it, it will display with a dot. Okay, then followed by this, actually, this is separated by a dot like this. Then we'll have what is called as a microsecond, 6-digit number. So after the second part, this will be the microsecond. So every operation that you do in DB2 can be saved till the microsecond. If you do two operations one after other, it can be the same second. Till the second part, it can be same, but this part will be unique always. Okay, you can't have the same operation done in the same time. It's not possible. So at least some second differences will be there. So DB2 from in the past, they have been doing this. I don't know now, they might have even gone up to nanoseconds. But yes, up to microseconds is always available. So this also we will see when we declare object tables, and we can see how this timestamp object comes into. Since you said you didn't work much on DB2, I am probably going a bit slow on DB2. Okay.
Okay.
Then coming to string, we'll have different types of strings. Generally, character string is character data. So within character data, we can have character or varchar or long varchar. Long varchar is for double byte characters like other languages, right? Apart from English, if you want to support other languages like Japanese and all, they will go for double byte. So that's where they use that. Yeah, sorry, not that one is graphics, double byte. This one, sorry, that one is graphic, var graphic, long var graphic. That's double byte. This one, long varchar, is much longer value if you want to store. Varchar itself, it can have a lot of storage, but I don't know if you want a very long data string to be saved, like a file, the content of a file, then probably you can go for long varchar. So char is for generally shorter types, like for example, name or customer name, customer ID, customer social security number, all these things you can go for character. Whereas varchar is like customer address, customer email, so which can vary depending on 20 characters or 200 characters, then you can go for varchar. Okay, so depending on that you can use. So internally, depending on the data type that you use, the storage will also vary. Typically, this is the storage it will take, as I showed you, timestamp, right? The timestamp will be in this format. So date and time standard formats, and small int will take up to 2 bytes, whereas integer will take 4 bytes, and decimal x comma y. X comma y up to 31 digits we can give. So this x comma y, what it means, must be aware of that because we'll be using that. So whenever I say decimal, let's say 7 comma 2, it means it is 7-digit number inclusive of decimals. So it means when you convert this to COBOL, it will be looking something like this. Picture 9 of 5, V 9 of. So you have to keep in COBOL, its representation is different. Here 5 plus 2, but here it is 7 comma 2, means 7 includes the 5 and 2. So 5 plus 2, the total is 7 here, out of which 2 digit is decimal. COBOL, we will represent it like this. I hope you are able to understand this, right? So
Yes.
this one you have to keep in mind. This is COBOL 5 plus 2, that is represented as 7 comma 2 in column of a table. So, and character up to generally 255 bytes, we go for character. Anything beyond that, we should go for varchar. So those are the things which is explained here. We don't use graphic, where graphic, I think I've not used that. It is similar to string, but it will support DBCS, double byte. That's what we don't use it here. Maybe in countries like Japan, they will use that. Numeric data types, there's nothing much, float, real, and I can have all that. Yeah, we can try all this. Try this date, time, and timestamp. That's it. Okay, so as I told you, the categories will come under DDL, DML, DCL, okay, and TCL, transaction control language. So what are the DDL statements? Create, alter, drop, and delete. Oh, we don't use delete in this thing. I mentioned delete, right? Where is my DDL? DDL, you will not have delete. We call it here. Okay, create, alter, drop. Whereas the delete will come under DML. Okay, drop means remove the object. Rename also we can do. That's not so used frequently. DML, we'll have this. Though the select statement, strictly speaking, it's not a DML. It's called as a data query language, but normally they will put it under DML. DCL, as I said, grant revoke. But strictly speaking, commit and rollback should come under TCL, transaction control language, but sometimes they include it under DCL if they don't specify TCL separately. Similarly, DQL also, some people, they don't specify it separately, and they were all added in later. So what is the syntax for create table command? So we just say create table name, and then column name and the data type. We have seen any one of the data type. We can give null. Not null is not valid. If you, sorry, null is not valid. If you say not null means you have to enter data into that column. Otherwise, the insert statement will fail. Primary key, if you designate it as a primary key is a way of uniquely identifying a record. So, for example, in an employee table, employee ID or PAN number or associate security number, none of these can be primary key. In India, we have many things like Aadhaar number, PAN number, many other identifications, which can be unique. So, and then we have the concept of foreign key, which you will see as we do the practicals. We'll see that. So in DB2, when we create a table, the table will be a part of a database. So the database must be first created, and within the database, there will be many objects. Okay, so let me just put briefly here. Maybe I don't have the board now. So a database will have many objects. Okay. So the lowest level object the database will have is called as a storage group. So this is what will be your VSAM LDS files will be connected to. It will be declared, and then you have to declare that along with the VSAM LDS files. So actually, all our DB2 will use LDS files. So whatever objects you create, ultimately anything that you do store in DB2 will go to LDS files. Okay, the VSAM uses, so the connection between the objects and the these are all logical objects, this storage group and all, which we use inside the DB2. So storage group, we will connect it to a actual physical LDS file. Okay. Then a storage group again is divided into table space and index spaces. So under the, any storage group will contain multiple table space or index space. Every table will have an index, not mandatory, but generally it is used. The index will come in index space and table will come in table space. So then we have the objects like table or index, and there are many other objects like views, alias, sequence, all these are other objects we'll see. So these are all the DB2 objects. So the lowest level object is storage group. Storage group contains table space and index space, and table space will contain table, one or more tables. Index space will contain index. So, and there are other objects that will also be stored under the storage. Okay, we use alias and so on. So this how you should look at the how internally DB2 organizes its data in form of the different objects. Okay, so 99% of the time we will be dealing only with this, or I would say 90% of the times. So only sometimes we will, of course, whenever you use primary key and all, we have to create an index. So we'll use index for the table. So normally when we create a table, we'll also create an index. Then other objects we will use as required. Okay. So when you declare a table or when you create a table, apart from the columns, you also have to give where this table is going to stay. So you have to tell which database it belongs to. So there can be multiple databases. Let's say you can have employee database, you can have customer database, and so on, right? So in which database this table will be created, and which object will hold that whatever object that you are creating, it should come under some other object. So like table space will come in storage group, and the table will come in table space. Similarly, index will come in index space, but sometimes we don't have to give this information. For table, we have to give this. For index, we don't have to give because it will automatically know that it has to use the index space of that particular database. So the table, whatever table is using, the same database it will use, and it knows it has to use the index space. So you don't have to specify it; it will automatically take that. But for table, we have to specify this. Okay, so this is an example you can see here, create table, whatever we have here, right? Let's try to do it. The DB2 version that we are using here, let me swap this. You can see my TSO screen, is it visible? Or
Yes.
should I? No, the characters, I mean.
Yeah,
Readable?
it is visible. Yeah.
Let me log in to my ID. So let's try to create some tables. You can also try it later. So how to go to DB2? We saw yesterday that there are two products which we can use, Poofy and QML. So first of all, I'm going to create, or let me see whether I already have it. I think I may have it, l.sql, lms.sql, I think. Yeah. So you can create one library for SQL, and then we can create objects in that. Okay. So let me use this and create some objects. Oh, already I have something. Okay, let me use another library so that I can refer to this as required for the syntax. I'm going to create a new library, allocate. Let me call this training dot SQL. It is also there. Okay, now let me call this. Okay, call this as April 26th. When did we start this training? In April, right?
April 19th.
Do you remember which date we started?
I think 19th.
19th April. Oh, it's going to be 2 months. That's a lot of time. I'm going slow. Actually, we have to speed up. So April 26.sql. I'm removing all this. Give that space as
That's
tracks.
April 21st.
Okay. All right. So let's use some. Ideally, we should be able to finish in about 7 or 8 weeks. But unless I have recordings, I can't do that. So unfortunately, I am not getting time to do any recordings. So then we can speed up so that you can look at recordings for certain topics. So we can save time. Anyway, so record length 80 library. So I'm going to use this April 26 for this training. So let's go for this. Now, how to go to the Spoofy. So you go to start menu. From the main menu, you click on EM, right? More. And then here, there is, you can see that QMF is there. But I'm not going to use QMF. I'm going to use Spoofy. For that, you select this DB2 version 13. This is one of the latest versions of DB2. I'm going to select option 14 here, which is DB2. Then I go in Spoofy here, the first option, right? Then here you have to give the name of the object that you want to create or the SQL that you want to write. So in my case, I'm going to say April 26.sql. First, we have to create the table space. In DB2 version 13, they made one change. Earlier, we used to have in the older versions of DB2, in one table space, there are 3 types of table spaces. In one table, say simple table space, segmented and partition. Let me briefly mention it here. Within table space, we have 3 types. Simple. A simple table space can have 1 or more tables. And segmented, this also can have 1 or more tables. And the third type is called partition. This can have only 1 table. So in one table space, it will allow only 1 table. This is called partition. This is generally used for large data, right? Let's say I have transactional data, right? I will generally go for partition because millions of records will be there. So I allocate the entire table space for just 1 table itself. But if it's a medium sized table or small tables, you can go for simple for very small tables. Segmented is a little more efficient than simple. Simple will the problem. I mean, simple table space is supposed to be used only for very small tables, like 100 rows, less than 1,000 rows or something. But if you want like 50,000 rows or 1 lakh rows like that, it's recommended to go for segmented. Segmented will be slightly different in the sense the table is divided into the table space is divided into segments. Okay. And one table data can be stored in one or more segments, right? And but one segment cannot contain data belonging to multiple tables. So I don't have the pen now, otherwise I could have drawn a simple diagram to show this. This is very simple. So the table is divided into segments. So and each segment can hold some data, but it cannot have data mixed with multiple tables. So basically, one table can be stored in multiple segments. So like that, if you have 10 tables data can be stored in different segments. But the segment within the segment, you can't mix up the data belonging to multiple tables. So this way it will be more efficient when you retrieve the data. So it will only pick up the segments belonging to that table, right? So that way it will be more efficient. The data will be spread across the table space, but efficiently it will be picked up. But whereas in case of simple table space, what happens is it will load the entire table space itself to fetch your data. So it will be a little inefficient. That's why it is not recommended for efficiency if you have to go for segmented tables. Okay. But in DB2 version 13, what they have done is they said even these two they removed. Okay. They said one table, one part, one segment, table space means 1:1. So there is no mixing up at all. So it will be very efficient. You can store any amount of data. So that means if effectively they said you can use only partition. You cannot use the other two types of table spaces. You cannot create. So that is the thing that they developed in version 13. In older versions, we have this, so should be aware of that. Okay, so we are using version 13 here. So it doesn't allow here simple or segmented table space. It doesn't allow you to create in this particular DB2 version. So we can create only partition table spaces. So first we have to create a table space. That means for every table, you should create a table space. Okay, database, of course, there is only one database. First, we will create a database. So I will say create DB. So we'll try to create a database here. Then we will use, we'll create objects in the database. Let's try it. So you can you can probably try it, should work for you. I am suspecting you may get some error. Let's see if you get, we have to give some authorization for your ID and all that. So you may get that problem. We will try that today itself. Let me first try it, and you can also try that. What I can do, April 26.sql. Let me refer to another data set so that I will not lose time on the syntax. So let me go here. Like demo. First, let's create a database. Yeah, demo. No, for creating, I think we already have a storage group in which first you have to create the database, then you have to create the storage group, then you have to create the table spaces under that. So I don't know whether I have the command for that. Search. I don't think I have. Anyway, let's use the existing one. So let's take this and try it out. Okay. Probably make some changes here. So I'm going to create a new table space. Okay, what I will call this tables, because one table will go to one table space. So I'm going to use the demo database, which is already there. So you can also use the same thing. Now, this table space name, I'm going to use, you can use demo. I'll probably use a different one here. I will call it April 26 table space, April 26 TS. I'm dropping it. If it is already there, I will drop. I don't have it. So I'm commenting this line. How to comment line in SQL? You will just give a double slash dash. It doesn't follow any column specific thing like COBOL or JCL. You can type it freely. Now, first you have to create a table space before you can create the table, right? Let me, when you press F3, it will come out. If you give S again here, it will go and edit it. Anyway, I have to give a different name here. It's not create DB, it's create table. Let me do one thing. Let's go here. April 26 dot SQL. I'll just rename it to create table, right? Let's put rename create, or I will just say table create. First table I am creating, right? I will say tab 1 create. I'm creating the first table. Now let's go here to the spoofy. Tab 1 create. I'll edit it here. So the name of the table space is what I gave, April 26 TS. I have to give here April 26 TS. I'm creating it in the demo database using this storage group. So that is fixed. Will not change this 2 lines. There are some other options. These are optional. So I'll remove this. Commit means you want to save the changes permanently. Right now I have commented it. Later on, if required, we will use this. Commit and rollback. These are the two TCL commands. Rollback means it will undo. Commit means save. Permanently save it. So now only one table we can create. So I'm going to create a department table. Let's go back here to the PPT. So the PPT, we can see create table department, department number and department name, right? Similarly, we'll create table department. Okay, I will give department number. We can say department ID or department code. Normally we use number only. We use the department number. Department. Yeah, we can use code or number, doesn't matter. So I'm going to give only 3 or 4 characters here. Let's say I give 3 characters here. Not null means this data must be entered when you try to insert a row. Primary key means I want is to be used as a primary key. So primary key will tell that it's going to be unique. Primary key, when you say, it has to be unique. It can't be duplicate values. Now department name we can put department underscore name. You can have a varchar or char, it doesn't matter. So not null means you must enter this. If you remove this, it means you need not enter it. Okay, it can be null. So let that be null. That's all, only 2 columns. Let's try this. The table space name, I have to change it here, demo DB. The table space name I'm going to use is April 26. Yes, for every table we have to create a table space, right? So then this will not work because every time I can't use the same thing. So I'll have to use some naming. I will do one thing. Whatever table I am creating, it has to be unique also. How do I make it unique? When you try also, it will create a problem. But, don't know whether it will create a problem. Let's see. Now I will give table space. underscore some kind of naming convention I want to follow. This table space is for department table, right? So I will give like this ts underscore department. Here also I give ts underscore department, the table name. So this table space is meant for this table because only one on one we're going to have. We have to create an index. So here I will give this index name as ix underscore table name on department table. This is the name of the table. And the key column name is department number. So I'm creating a unique index on that, right? So you can see that here, create unique index on that. So that's what we are doing. So let's try whether this will work. See. So invalid character found, all that syntax errors you will see, but I will give this code so that you can do it without making mistakes. So what is the syntax error here? Create table space. Oh, it doesn't allow underscore. Okay. In the table space. So let's remove the underscore here. Call it as TS department. Here also. Let's to execute it. I just press F3. When I press F3, it will come back to the previous screen. Then execute default. When you press enter, it will execute and it will automatically commit this and it will show you the output. Output will go to this file called your id.spoofy.out, whatever you give here. Okay. So that's what it will do automatically. 3 steps it will do in one shot. So now it will execute it, auto commit it, and then it will open the output file. So this output file, it is opening in the browse mode. So you can open it in another screen also, but it does it for you automatically here. Now you can see every SQL, when you execute, it will give a message. The message will always start with DSN. This is a standard thing. DB2 messages will always start with DSN. Some code will be there. Then some message here. This says execution was successful. And every SQL that you write, you execute will give a SQL code. So here we have seen SQL code is 0. Okay. 0 means successful. Always remember in mainframe, mostly 0 means successful. JCL also we get max is 0. COBOL also you will get the compilation return code 0, right? So 0 means successful. When you read a file also, file status 00 means successful. Open the file, all that. So mainframe, 0 generally refers success. Okay. So I committed this. This one I did not commit. I just created the table space. I want to both of them to do and then commit it. So the table got created successfully in this table space. And SQL code is 0. Then I am automatically, I didn't give a command, commit command. Commit automatically it performs because that's how a spoof is configured. If you want, you can give no in the previous screen, but I gave yes, so automatically it is committed. Now this table space is created successfully. You should always scroll through the end and you should see this message, commit performed, SQL code 0. Then only it means that all the statements that you have given executed successfully. Otherwise, any one fails, it will automatically do a rollback. Okay, if I try to run this again, so I'm running the same thing. Now I am opening it. Press F3. Now look at this. I'm executing the same query again. Now this time what happens? We have already created the table space, right? You can't have two table spaces with the same name. So you will get a error message here, SQL code -601. It means the object already defined. Duplicate name, right? Identical to existing name. So it won't allow. Means this particular SQL failed, right? You can see the first moment one SQL fails, it has done rollback automatically. It means undo. Okay. Whatever SQLs you have written below that, it won't get executed. Okay. So it will go sequentially. If any one SQL gives error, anything below that, it won't run. It is similar to the abend in JCL. In one step abends, any other step below that will not run in JCL. Okay. Similar to that. So this is how we can create a table space. Now we have created a table space, and within the table space, we have created a table. Now, if you want to insert some rows in that table, I'm going to just say here insert, because we have only 2 columns. We can do that easily here. Let me, yeah, let me type from here only. So insert, the DML for that is insert into table name. My table name is department, right? Department. And then you have to give the column names here. The column names is department number, comma, department name. Again, if you don't give this also, it will work, provided you give what is called as a values class here. Values. Let's say I want to give D01 here. I don't know how many characters. I think I gave 3 characters, D01. So I'll just say department 1. So like this, I can end the SQL with a semicolon. Normally, I prefer to give it in a separate line, though you can give at the end of the line. Sometimes I do that, but mostly I prefer to give it separately. Let's say I'm inserting 2 rows, right? Then I want to see whether the insertion, I want to see the content of that. So I can give a select statement. Select star. Star means show me everything from the table. So this department. So that's it. I'm asking show me all the rows, all the columns. So let's see whether it works. So you can see SQL code 0, 0 means these 2 statements got executed successfully, and you can see the data is now available in the table. But if I try to run this SQL again, what will happen? Now again, I'm trying. I press F3, enter. Now what happens? This particular column we have declared as unique, right? Unique index we created. Means it has to be unique because it's a primary key. So if you're trying to insert the same value, you will get minus 803 SQL code means duplicate. Last time we got for the object, we got minus 601. For data, we will get minus 803. So it will not allow you to insert. You have to either change this or you have to delete it and insert it again. So one way to do it is you can add a delete statement here. You have to be careful. When you say delete from table name, what it will do is it will delete all rows in the table. You have to be very careful when you do this. First, I'm deleting everything, so I will not get the duplicate issue. Okay. I can keep on doing anything I want. I won't get a duplicate problem because I'm deleting everything and I'm starting fresh. So now you can see it inserted successfully. Okay, till the last line, you can see it got executed. So for testing purpose, we can do this delete, but in production, they will not use projects and all, they will not use. Even if you use delete, you will delete only specific rows. This delete will delete everything in the table. If you have 1000 rows, it will delete all 1000 rows. Okay. So you have to be very careful with that. So these are the statements we did. Now what I'm going to do is, I'm going to ask you to execute the same thing so that I want to know whether you have permission to do it. Otherwise, we have to resolve the permission issues today so that the next class, at least you will have the permission to execute these things. This weekend, please do COBOL. Huh? Don't forget COBOL. Eventually, we will get into COBOL. That's why after SQL, again, we will get into COBOL only. That's why. Okay. So SQL, of course, you can do it next week. We can practice, but I want to ensure that you don't have any access issues. That's what I want to check now. So what we will do now is I am going to ask you to share your screen and log in, and I will give permission for my data set. So you should be able to open the data set. So just a minute. Let me do one thing. So my screen is still visible.
Yes.
Okay. So what I'm going to do is I'm going to give a command so that you can access this data set which I created, April26.SQL, right? I want you to have read access to this. For that, there is a command that's called as a security command. So I'm going to do that. I have a JCL to run the command. I can run it manually also, but I'm just referring to the JCL here. Going to JCL. So let's this is the command. Let me just execute this command in the command prompt. So let me. So I'm going to permit this April 26 dot star to your ID. So what is your ID? TAPP
001.
001. So you should have read access. Okay, so that you can copy this SQL and you don't have to type it again. You can just execute it. So for that, I have to define a profile. So okay, that's why I prefer to JCL, add the profile and do it. Okay, let me go to JCL. It's my JCL. So I will give you access after that you log in, so that sometimes access will get effective only when you log off and log in. So that's why I'm trying to do it. Select. I'll create April 26. So I'm going to give you read access. Let's do that. I think now it should work. Okay, so now it is done. So now you should be able to access my whatever I put in April 26. Should be able to access. Okay, do one thing. I'm coming out of share. Can you share your screen and show me?
Okay.
I want to ensure whether you are able to execute these SQLs. At least the create table. Once if this works, then all other SQLs will work. First, we have to see whether you have access to create the table space. Yeah, that's good. Visible now. LTSO.
What happened?
L space TSO. Just type L space TSO.
Yeah, that's what I gave.
Yeah. Okay. So
You want
now,
me to copy first?
yeah, copy. Or because I create this thing SQL library. What is the convention you are following? Your ID dot something, right? Lakshmi dot SQL. Yeah. So library, give it as library. In the dataset name type, yeah, library.
That's it, right?
Okay. Yeah, that's it. Now go to 3.4 and go to open my dataset there. TRNR004 dot April 26. Yeah. So now go to that SQL, give a V command view. Yeah, you have access. Now give C in both the commands. C, just give copy C in both the members. Yeah, enter. Now you give lakshmi.sql. No, you don't give a quote. If you give a quote, you have to give the ID. The ID will be automatically prefixed if you don't give the quote.
Okay. Enter.
Enter. Then now it's copied. Now go open another screen. Do it properly. No, not 3.4. Just say start. Just say start. Go to M. We have to go to SQL. No, option M, and then third. Is that 14? 14. Yeah, here you give 1. Okay, this one, the setting we have to do. Hold on. Stretch. Okay. Enter. PTG. Type 7. Not 7. F3. I think it's 8. Type 8. F3. 8. Not this. F3. I did it wrong. I think it's D. DB2 I defaults D. Okay, here you have the first line, no DSN. You have no first line. That you change it to DBDG. Database DB-DG. That's it. Enter. Okay. Enter. Okay. Now type 1 spoofy. Okay. Now give lakshmi.sql without quotes. Bracket open. The member name, which is, what is our member name? Hold on. Tab 1 CRT. TAB1 CRT. Bracket close. Tab, press the tab 2-3 times. Go to that line 4. Go to the line 4. Yeah, give spoofy.out here. SPUFI.out. This is our out file. Now again, tab, change defaults, make it no. Yeah, we don't want to change any default setting here. Okay, that's it. Press enter. Enter. Okay, now we got this. Hopefully you should be able to run this. Let's see whether it allows. Okay, F3. Enter. So that table space is common because we are using the common database, right? So I have already created TS department. So it's saying it is already there, right? I showed you this. So we should give a different name for you. For any tables that you create, we should use a different naming convention. Okay, F3. Enter. So we'll give a different name here. Because we are using the same table space, right? So what we will do here is change the table space. Okay, reset. Give a reset. Now the table space name you change it. I have given us TS department, right? That's what I was thinking. What is the naming convention we can give? So you can say all your table spaces. You start with TSL. Okay, TSL and then DEPT. So that we can differentiate. Okay. So that should be your table space. So in line number 16 also you should make that change. Yeah, all your tables and table spaces you start with TSL. Okay. So that will be unique. So other things can be same. Table name can be same. But because within the table space, the table is going to go. Okay. So now F3. Enter. Okay, good. We have authority here. Go down. F8. Okay, it got created. You can see commit performed. SQL code is 0. So now there is no authorization issue. Okay, F3. Now tab 1 INS. Change the member name. Insert that other second member. Line number 1. Yeah. Tab 1 INS. The member name is insert. Yeah.
Enter.
Enter. Here you don't have to make any change because the table name you have to change. Yeah. Table name, no, you don't have to change because only the table space has to be unique. The table name is same only. Okay, F3. Enter. So go down. So you can see it's inserting data in your. Both of us, we have the same table name, but our object, the table, it belongs to different table spaces, right? Have you
Mm.
understood? So two
Mm.
different table spaces are there in the same database, DemoDB. You are using TSL starting table space starting with TSL. I'm using table space starting with TS. Okay.
Okay.
So that's the difference. Yeah, I think no authorization issue. So we should be able to do many SQLs going forward next week.
Okay.
Because I don't think already it's more than an hour now. So yeah, so at least you can try SQLs like this. I've just shown you one example of how to create and insert some data, small data. But if you want, you can try. Otherwise, we can continue next week. I would suggest you to focus more on COBOL.
Well,
SQL is easy. Try to do the assignments, some assignments, pick up randomly and try to do that so that it will, if you are stuck with something, yeah, let me know. We'll look into that. Yeah.
sure. Yeah.
So next week we will do more SQL practice. I'll give you more assignments in SQL also.
Okay.
Okay. So you can try the different database. So this sample, we will create some examples that is for understanding the syntax. But I will give you a database, I will some create table commands and all that we'll give. We'll focus more on the select statement because that is what is important. So the more of the assignments will be on the select statements. So create table and all, this is simple. You can see that you can do it like this.
Okay. And may I know like how many more classes are there?
I don't know. To be
Okay.
honest, we have not
Okay.
done this retail training in the recent past, so I don't know.
Okay. Okay.
Um,
No issues. No,
uh,
I'm just checking like from tomorrow, like kids are like getting holidays for two
oh my
months.
God.
So I'm just thinking like to switch the time. I mean, if I'm not comfortable like this time, I don't know whether they'll sleep by this time if the
No,
holidays
then why,
ends.
what about your morning?
My morning, that's what I'm thinking. Like early morning, maybe at around 6 o'clock. It would be like your evening 6:30. I'm just thinking.
Yeah,
I'm
yeah,
not
we can
sure.
plan
Like
like
if you're
that. Yeah,
available,
yeah.
I'll just think
No,
of
no,
the time
we
and I'll
will,
let you know.
yeah, yeah, I will tell you, I will also prefer that.
Mm.
So, but initially, maybe if I have some other training, some days we may not be able to have it, but mostly I should be available most of the days.
Okay,
In
I'll
that
just
case,
think
I
of it and
suggest,
let Kirtika know then.
huh?
I'll just think of the timing and let
No, no,
Kirtika know.
it's okay. I mean, I suggest you get up early before the kids get up.
Okay.
Okay. Well, just get up early, have your tea or coffee, and sit with your tea or coffee to the class, so that by the time kids get up, your training is over, your class is over,
Yeah, true. That's
so
what
that the
I'm
whole day
thinking.
you will be having
Tomorrow
the
is the
time.
last day for them, so I don't know. They'll now it is like as there is school tomorrow, so they'll sleep by this time.
No,
So
no.
if no school means
Anyway,
yeah.
tomorrow we will not have class. So tomorrow is Friday for you, right?
Tomorrow we don't have. So
Uh,
maybe yeah, I'll think of it this
you tell
weekend.
me the
I'll
time evening. I
yeah.
suggest you pick up your early morning time. The
Mm,
earlier it is, the better it is for you. For me, it is evening.
mm.
For me, it's not a problem.
Yeah,
So you
yeah.
select
Okay.
a time to ensure that you get that 1 hour or 1.5
Mm,
hours. Allocate 1.5 hours.
mm.
Let's say the kids will get up at 7. Then we should start the training at 5:30 your time.
Oppo.
So
Okay.
so you have to manage it your sleep
Mm.
so that
Mm.
the whole day you will be free. No, so that's what you have to see. So you will have a free time the whole day to manage whenever you want to do some practice, right? So
Mm.
otherwise evenings anyway you will not be available, right? So that is the reason.
That's what I'll just think of it. Yeah, I don't know. We'll
Plan
see
it because this,
these 3 days. Yeah, I can see like whether kids sleep by this time or not. So
or you this otherwise you have to extend this time only. No, now it's what we are starting at 9 p.m. your time, right?
yes.
Instead of 9 p.m. we should make it 10 p.m. or 10:30 p.m. your time.
Oh, that will be like too.
Yeah, then you will be sleeping.
I'll be sleepy by that time.
That is why I'm
It's not
suggesting
at
get
all
up
possible.
early.
Yeah, yeah. Now daily I'll wake up at 5:30 actually
Huh,
daily.
okay.
Uh, But the thing is, like, kids has to go by 7:30. They should start from home by 7:30 at 7:30.
Yeah, now when the kids
So,
don't have school, you still do the same thing. I'm
maybe I'll
saying,
see.
let's start the class at 5:30. You just wake
Mm,
up few minutes earlier for refreshing, and then
mm,
5:30 to 6:30 or maybe 6:45 like that, we will have the class. So
5:30
that
means
would be
I should
better.
wake up at I should wake up at 5 itself, no?
Okay.
For Okay, I'll just think of it and I'll let you know.
Yeah,
The
you can ping,
the timings.
or you can send me an email. Okay.
Sure, sure.
You can copy me and Kirti, both of us.
Mm-hmm.
Kirti's email you have?
Yes, I have it. Yeah.
Yeah, you can send to both of us so that we
Okay.
will be in
Yeah.
sync. What time from next week? That is from your Monday, right? Your Monday
Monday.
evening or Monday morning, you have to tell that. Accordingly, we have to plan. Will the
Okay.
Monday morning
Okay.
be okay for you? Your time? Don't know. You have to think.
That's what today's health.
Okay, whatever
I'll
it is.
email you. Yeah.
You email us. Okay.
Before Sunday, yeah, I'll mail you.
Okay. Yeah. You inform us so that we will plan accordingly. We'll stick to one time so that there won't be any confusion. Okay.
Okay.
All right. Okay.
Yeah.
All right. Thank you. Bye bye. Good night.
Thank you. Bye.